We once thought 3I Atlas was nothing more than a stray interstellar rock, until the moment NASA's cameras captured movement inside it, a rhythmic internal shift that didn't match anything natural. Then came the pulsing electromagnetic signals, the self-correcting trajectory after passing through Jupiter's magnetosphere, as if it knew exactly where it was going. That's when scientists were forced to propose a bold new idea. Could this be an ancient vessel, a memory archive, or a biological seed pod awakening after billions of years? But the strangest part, it didn't communicate, didn't attack, didn't send a message. 3I Atlas simply continued on its path, leaving humanity more humbled and more curious than ever before. If you enjoy science stories that challenge everything we thought we understood, make sure to like and subscribe. Let's dive in. Far beyond the orbit of Neptune, in a place where sunlight fades into a pale and almost silent trace, an object moves through deep cold. It is older than any record humans have written, older than any culture that has risen and fallen on Earth. In this distant region, where the solar system loses its familiar shape, everything becomes quiet. Comets that have not seen light for billions of years remain still. Nothing changes unless something forces it to. Yet inside this quiet zone, something does change. Data begins to arrive from a distant monitoring array operated by NASA. The signals do not draw attention at first. They appear almost like background noise, only a tiny variation in a long stream of routine measurements. But the same variation appears again and then again, across 3 different instruments that do not share the same hardware or calibration methods. When the readings align, a pattern becomes clear. Something inside the interstellar object known as 3I Atlas has shifted. Cameras show no evidence of dust impacts, no cracks forming from rapid heating, and no burst of solar wind that might disturb its interior. Instead, the sensors detect something far more unusual. A small movement inside the object, only a few meters across, repeating with steady timing. The motion is faint yet regular, almost like a mechanical pulse. Astronomers know the behavior of comets, asteroids, and icy bodies. They fracture, vent gas, or spin irregularly under sunlight. But none of them move from the inside with such steady rhythm. For the teams watching the data, the atmosphere changes. This is not a familiar kind of motion. The object itself keeps drifting through the dark, still covered in dust and ancient ice. It is not large. It looks like many comets observed through most of the 20th century, but it has behaved strangely since the moment it was first detected. Its speed was too high. Its arrival path was too direct. Its approach angle did not match the way natural objects usually fall into the solar system. It moved with a precision that felt out of place for a simple fragment of rock and ice from interstellar space. Even with these unusual traits, scientists kept their focus on natural explanations. Space is full of rare conditions, and unusual objects do pass through the solar system. But once the internal movement was confirmed, the sense of distance faded. The object no longer felt like a silent comet. It felt more like a sealed structure that had stayed dormant for longer than life has existed on Earth. Thermal instruments then record a sudden drop in temperature of nearly 100 degrees Celsius, falling too quickly for normal processes involving frozen materials. The drop suggests that heat was pulled inward, as if the interior absorbed energy rather than losing it. Moments later, the temperature rises again. Soon after, sensors detect a faint electromagnetic pulse, repeated in a short sequence. The pattern is simple yet clear enough to stand apart from natural background variation. It resembles the startup of a system rather than the random output of physical stress. Inside mission control centers, the usual noise of quiet discussion fades. Researchers examine the incoming data, watching figures update faster than they can comment on them. Even those with long experience in deep space observation feel the weight of the moment. Objects in space do not shift internally without a reason, and they do not normally produce signals that follow a timed sequence. The object remains visually calm, showing only a faint green glow across parts of its surface. The glow has been noted for months, and scientists have not yet found a natural explanation. No known process in a simple icy body produces such stable coloration. With the new internal motion, the glow no longer seems like a surface oddity. It may be connected to the activity inside. 3I Atlas continues moving through the outer solar system, slowly rotating. It responds to no visible forces, yet the timing of its internal motion hints at awareness rather than accident. The silence around it feels heavier. The object gives no direct information. It only offers the repeated motion that defies natural behavior. Whatever is inside it has remained inactive for longer than the solar system has existed. The surrounding darkness seems to press closer as it travels, almost as if the void itself is holding its history. It may have moved between stars for billions of years without being touched or observed, carrying a purpose hidden beneath layers of material older than Earth's first oceans. And now, as it passes through a system populated by a young technological species, a part of it has awakened. Engineers and scientists search for explanations that do not involve intention. They consider whether trapped gases may have shifted inside, whether internal cavities may have collapsed, or whether particles aligned under changing magnetic conditions. But none of these processes produce rhythmic pulses. None of them synchronize with electromagnetic activity, and none of them repeat with the stability now recorded by multiple instruments. Researchers begin private messages and quiet discussions. Draft reports use the word mechanism, then remove it, then add it back. The difference between a natural phenomenon and an engineered artifact is large, and no one wants to cross the line without certainty. Yet the data does not behave like a natural process. It behaves like something designed. The object keeps moving, quiet, but no longer inactive. Its moment of internal activity is enough to change the direction of scientific attention around the world. The data increases, questions multiply, and the sense of concern grows. Whatever has moved inside the object is not random. It follows a pattern that suggests a purpose beyond the reach of standard models. A faint tremor from deep space has become impossible to ignore. Long before it captured global attention, 3I Atlas entered scientific records in a far smaller way. On a calm night in Hawaii, a telescope detected a faint streak across a sensor. It looked like a small smudge among many others recorded that night. Its early measurements showed nothing dramatic, but its path stood out immediately. Most small objects follow elliptical orbits, held by the long history of the sun's gravity. This object came on a hyperbolic path, one indicating that it did not originate from anywhere near the solar system. Its speed pointed toward a distant origin, and its angle of arrival was almost perpendicular to the disk of the galaxy. Observatories around the world confirmed the detection. Data came from facilities in Chile, South Africa, and the Canary Islands. Within hours, it was labeled an interstellar object, the third known visitor from beyond the sun's influence. The announcement recalled earlier cases like 1I Oumuamua and 2I Borisov, but this new object carried a different set of properties. It appeared colder and less reactive, and its early measurements did not match the behavior of a natural comet. When orbit calculations were refined, scientists realized that the object had not come from a known stellar stream or any region with strong gravitational influence. It had arrived from a part of interstellar space with almost no known star formation activity, an empty region where few objects are expected to form or travel from. It seemed to come from a place not just far away, but isolated. Early public reports stayed cautious. They described the object as unusual, yet natural, echoing standard scientific caution. But within research groups, interest grew quickly. Studies from multiple institutions began almost immediately. Those familiar with interstellar bodies noticed that 3I Atlas did not match typical profiles. Its velocity exceeded known averages. Its mass distribution hinted at internal differences not described by existing models. Even its light spectrum contained unusual patterns, showing dips and rises that did not match common materials found in comets or asteroids. Some features suggested layers or a structured surface. Research teams at NASA centers began forming task groups. Observatories prepared coordinated observation schedules, hoping to capture as much data as possible before the object moved too far inward or outward. James Webb Space Telescope review committees drafted new proposals within only a few days. The observatory, commonly called JWST, had not been built to follow fast-moving targets, but later software upgrades had given it that ability. In less than 1 week, a wide observing campaign took shape, bringing together teams from many institutions. Space-based instruments would examine its heat and composition, while ground-based telescopes would be responsible for tracking how its brightness changed in visible light, carefully recording its optical signature. Hubble was scheduled to measure the object's ultraviolet reflectance, while the James Webb Space Telescope, often called JWST, would study its infrared spectrum to look for signs of different ices and minerals. As 3I Atlas moved slowly closer to the outer regions of the Sun's influence, its behavior became more unusual. Its rotation did not follow a simple, steady spin. Most small bodies in space turn in a stable way, their motion shaped over long times by gravity, impacts, and gentle jets of gas. 3I Atlas, however, showed a slight wobble that refused to match standard models. The way it turned suggested either that its mass was unevenly distributed inside, or that its body was built in an asymmetrical way beneath the dust and ice. Then, another feature appeared. Instruments began to detect a faint greenish glow coming from its surface, even though it was still millions of kilometers away. At first, many scientists thought this might be fluorescence, a glow caused when solar ultraviolet light strikes certain gases and makes them emit visible light. Comets often show such behavior, but the exact color and wavelength did not match any known pattern of comet activity. The light did not strengthen or fade in step with the changing solar input either. It stayed surprisingly stable. This made the glow look less like a side effect and more like a distinct signal. Even with all this, most teams still treated the object as a very unusual but natural body. The universe is huge, and even extremely rare combinations of properties must exist somewhere. Still, suspicion grew when researchers traced the path of 3I Atlas backward through space. When they reconstructed its trajectory in time, they found that it did not seem to come from the direct gravitational influence of any particular star. It appeared to have drifted in from a quiet region, as if it had been slowly released, not thrown out by a violent event, like a close stellar encounter or a supernova. It was more like a capsule that had gradually slipped free of its original system and then moved on for an unknown length of time. Days turned into weeks, and observing teams rushed to gather as much data as they could before the object moved away again. The solar system does not receive many confirmed interstellar visitors, and very few remain stable and bright enough for detailed study. By the time 3I Atlas had passed beyond the orbit of Mars, the mood in the community had shifted from cautious interest to focused anticipation. Instruments were calibrated for more precise infrared mapping. Hubble waited for the right alignment to observe it in ultraviolet light. Then something happened that did not resemble any known behavior in the catalogue of space objects. As the solar wind brushed past 3I Atlas, its surface reacted in a way no one expected. Sensitive optical instruments recorded a wave-like disturbance moving across its outer layer. It looked like a brief, delicate ripple, similar to a pattern appearing for a moment and then fading. During that short interval, geometric patterns formed across the surface. Using image enhancement, observers saw arrays that resembled hexagonal tiling and spiral forms that spread across the dust-covered crust before disappearing into shadow again. The entire event lasted only seconds. This was the point at which many scientists quietly realized they were dealing with something that might be more than a simple lump of rock and ice. Complex geometric patterns do not normally appear and vanish across the surface of a natural object in deep space, especially not with such apparent order and speed. There was still not enough data to claim anything beyond an anomaly, and the community remained careful, but the event forced them to prepare for the possibility of deeper structure. The anomaly was logged, shared first within small professional networks, and then circulated more widely among observatories and theoretical groups. Theoretical physicists and astrophysicists began to discuss new questions. They considered whether the object might contain latent structure, such as networks of voids, layered internal regions, or crystalline frameworks that could respond to changing radiation and solar wind conditions. They explored models in which ordered matrices inside the object might shift or realign when exposed to certain energies. At the same time, teams continued to build practical plans for upcoming observations. No one yet knew about the internal tremor that would later change everything. At this stage in the timeline, 3I Atlas was still an unusual visitor, an interstellar body that did not quite fit any familiar category. The history of the object remained hidden under its outer shell. For now, it was defined by what instruments could see and measure: a peculiar orbit, an uneven spin, an unexplained glow, and fleeting geometric ripples. It moved along its path as a puzzle just beyond the reach of firm conclusions. The cameras were already on target when the first internal movement later took place, but in this period before the tremor, most of the evidence was still treated as scattered hints rather than parts of a single system. As 3I Atlas drifted deeper into the solar system, scientists began to assemble the individual anomalies into a broader picture. The glow, the irregular rotation, and the surface patterns started to look less like independent oddities and more like connected pieces. When analyzed together, they seemed to pull the object away from the familiar group of comets and asteroids and into a category that did not yet have a name. The green glow was the first detail to receive intensive study. At wavelengths where comets normally display emissions from gases such as cyanogen or ammonia, 3I Atlas showed none of the expected signals. There were no strong cyanogen lines, no dominant ammonia features, and no clear signs of typical ultraviolet-driven fluorescence. Instead, spectrographs recorded a narrow band of emission that did not match any well-known natural compound. The light was faint but steady, with a distinct emerald tint that became more noticeable as the object moved closer to the sunlit portion of its orbit. To casual descriptions, the glow might have sounded like the kind of after-image a person sees when pressing their eyes closed in the dark, a soft green haze. But the instruments showed that this was not a vague effect. The light was linked to specific wavelengths, and it rose and fell in step with small changes in the object's surface temperature. In other words, the glow was tied to thermal changes, not simply to changes in sunlight. It was not a simple reflection, and not just scattered solar light. It behaved like a response to conditions, as if something at or near the surface was reacting in a controlled way. The rotation raised further questions. Natural comets often spin in complex ways. They can tumble, precess, and change their spin rate as jets of gas push from different sides. Their motion can be messy and chaotic. 3I Atlas did not fit that pattern. Its axis drifted slowly, but the drift had a precise rhythm. It would rotate, seem to pause, or adjust by a small angle, then resume in a way that repeated over time. The adjustments were too ordered to be dismissed as random effects of outgassing. To some analysts, the rotation looked almost like a response to internal mass shifting, managing its orientation as though guided by an internal set of rules. Meanwhile, the object's outer surface continued to reveal subtle irregularities when examined with advanced imaging. Using adaptive optics to sharpen their view, telescopes detected changes in reflectance from one patch of the surface to another. Some areas reflected more light and gave a glass-like shine, while others appeared unusually dark, absorbing most of the light that touched them. These differences did not appear random. When researchers mapped them and applied statistical tools, they found recurring angles and alignments. Certain bright and dark regions arranged themselves in patterns that repeated over the surface. Most rocky bodies in space show rough, chaotic surfaces shaped by impacts and erosion. The reflectance pattern on 3I Atlas did not match that expectation. It looked more like sections with distinct material properties laid out in a non-random way. Scientists remained hesitant to use words like designed or artificial, but many agreed that the surface pattern did not behave like a simple debris-covered object that had been colliding with other material for billions of years. The first major attempt to analyze its composition in detail began when JWST turned its sensitive infrared instruments toward the object. Infrared spectra can reveal the presence of particular minerals, ices, and complex molecules by the way they absorb and emit light at specific wavelengths. In this case, JWST detected not only the sorts of bands associated with common ices and rock, but also additional absorption features at wavelengths that did not line up with any known natural mixture. The data hinted at structure on very small scales, perhaps arrangements of material repeated with high regularity, like a lattice. This suggested the possibility of a crystalline matrix with a level of order that conventional geological processes would not normally produce, especially in a small interstellar body. If correct, this would mean that the object's interior contained regions of material arranged with extreme precision, far beyond what is expected from random freezing, cooling, and cracking. The next key event arrived as the object passed through a region where it received increased energy from the sun. Instruments recorded a sudden internal temperature drop of nearly 100 degrees Celsius. The change was so fast that it did not resemble normal cooling, which would take time as heat radiated away. Instead, the data looked like heat being pulled inward, as if a system inside had suddenly absorbed energy. The temperature did not slide down a slope. It fell like a switch had been flipped. Moments later, the temperature rose again, just as sharply, reflecting a complete cycle. Soon after these sharp thermal changes, detectors picked up a repeating electromagnetic pulse. The signal was brief each time but returned at regular intervals. Its frequency matched those often associated with artificial currents, such as those running through circuits or controlled coils, rather than the broad and irregular noise of astrophysical radio sources. The pulse spread outward in a clean pattern that lacked the messy structure of natural cosmic electromagnetic activity. The more times the pulse was observed, the harder it became to write it off as random. Scientists across different agencies began to discuss the situation through secure channels. Some argued that the electromagnetic pattern might still be explained by complex interactions between solar radiation and strange combinations of subsurface material. Others suggested that unknown phase changes in exotic ices might cause such behavior. However, as more observatories, working independently, confirmed the same narrow-band pulses with similar timing, the explanations that relied only on natural processes started to feel forced. Another visual event followed as 3I Atlas moved near the orbit of Mars. High-resolution optical arrays captured yet another appearance of geometric formations on the surface. At first, they showed up simply as bright lines and shapes, but as software processed the images and corrected for motion, clear structures came into view. Bands of hexagon-like shapes repeated across certain regions. Spiral patterns traced smooth curves that did not resemble fractures or random stress lines. Once again, the patterns vanished within seconds. This short-lived behavior did not match the way ice cracks, rock fractures, or gas vents. Instead, it looked like a brief period in which an underlying layer became visible, possibly because the outer dust became momentarily transparent at certain wavelengths. It was as if something beneath, with an organized pattern, had been lit up and then allowed to fade. The same kind of geometrical signature appeared again a few days later, though more faintly. Even so, the repeated presence of such structure was enough to deepen concern. Structure, especially repeating geometry at large scale, implies order. Order often points to a process with rules. At least in human experience, such order is closely tied to design. Within the teams analyzing the images, quiet conversations shifted tone. People began to ask whether the object might contain hollow spaces beneath the crust, or layers of crystalline panels capable of responding to sunlight in complex ways. These were questions that a few months earlier would have been dismissed as speculation beyond the boundaries of normal astrophysics. Now they felt unavoidable. The situation grew even more serious when magnetometers recorded a weak but steady magnetic field surrounding the object. Small comets and asteroids of this size are not expected to have their own magnetic fields because they do not contain enough conductive, moving material to generate one. Yet 3I Atlas showed a field that varied exactly in step with the electromagnetic pulses and with the internal tremors later seen in other datasets. The field was not turbulent. It was consistent and displayed a clear pattern over time. Astrophysicists studying the magnetic data concluded that the field was coherent. That is, it behaved as though it were controlled by an organized source, not produced by random or scattered currents. This conclusion pushed the language of discussions into new territory. In private briefings and internal documents, some researchers began to describe the behavior as mechanical-like. They were careful to specify that this did not mean mechanical in the human sense of visible gears or motors. Instead, they meant that the system showed the qualities mathematicians associate with machines: regular cycles, constrained behavior, and predictable responses to inputs. As data accumulated, it became increasingly clear that the observed irregularities were connected. The way 3I Atlas absorbed and released heat, the pattern of its electromagnetic pulses, the small but precise adjustments in its rotation, the measured magnetic field, and the surface geometries were not independent accidents. They reinforced each other. They behaved like parts of a larger system that responded in coordinated ways to the environment around it. Researchers could no longer treat each anomaly as a separate curiosity. Taken together, they formed a pattern of linked signals. Something beneath the object's frozen outer layer was responding to light, magnetism, and heat in a controlled manner. Something long dormant seemed to be moving toward a new state, as if it had been waiting for specific conditions. The warmth of a star, the changing magnetic field of a planetary system, or the approach to a certain distance from a sun like ours. Whatever 3I Atlas was, it was no longer behaving like something content to remain still. Later, this turning point would be summarized in scientific records with short, careful phrases reduced to numbers, timestamps, and sensor traces. But for the people who watched the data arrive in real time, teams at Goddard, analysts in Pasadena, astronomers linked in from Chile, South Africa, and Tokyo, it felt like the moment when a long-standing assumption quietly failed. The cameras pointed at 3I Atlas were not just collecting light, they were recording the first clear sign of internal motion inside a body that, by every old model, should have been frozen and inactive for billions of years. It started as a change in brightness, a small flicker, a region of shadow shifting slightly beneath the dusty surface. 3 separate systems recorded it at once: NASA's Deep Space Array, the Hubble Space Telescope, and the James Webb Space Telescope. Each instrument worked differently, with its own design, sensors, and calibration. Yet the anomaly appeared at the same moment in all 3 data streams, aligned across tens or hundreds of millions of kilometers. The James Webb Space Telescope, with its highly sensitive infrared instruments, captured the clearest picture, a region deep inside the object, which had previously shown a stable temperature profile, suddenly distorted. The displacement covered only a few meters, but its shape did not match a landslide, a crack, or a venting plume. It looked like a contained internal shift, similar to how a panel would move or a compartment would slide into a slightly different position. At first, teams assumed the problem must lie in the measurements. They checked for calibration errors, software glitches, cosmic ray hits on detectors, temperature drift in the instruments, and mistakes in the processing pipeline. They compared raw data with processed images again and again, but the pattern did not disappear. It stayed fixed in time and position, unchanged by every correction applied. It was not a trick of light, not a ghost made by electronics, not an artifact of the algorithms. It was an event in the object itself. Then it happened a second time. Another small movement, again confined inside the object, again measured by multiple instruments. Hubble detected the same region as a slight shift in visible light. Ground-based facilities recorded a tiny but real change in the reflected spectrum. Once more, the James Webb Space Telescope provided the most striking detail. The internal area that moved showed a sudden temperature drop of almost 100 degrees Celsius in less than 2 seconds. In known astrophysics, only systems designed to move heat quickly can cool that fast. The drop in temperature did not follow a slow curve. It fell sharply, as if something inside had absorbed the heat in a single act. Right after the cooling, detectors picked up an electromagnetic pulse coming from within the object. The pulse was weak, but structured. It showed a clean oscillation, repeating with a steady rhythm, more similar to a controlled signal than to random noise. The frequency was low and distinct, appearing again as if finishing a preset sequence. Mission logs note that for a short time, many control rooms became very quiet. Within minutes, encrypted links connected NASA, the European Space Agency, and several major research centers. The phrase, mechanical-like motion, appeared in the first internal summary. Someone edited it to unknown structural displacement to avoid implying design, but another reviewer restored the original wording, step by step. Caution gave way to the simple need to describe what the data showed. The displacement was not violent. It did not send out jets of material. It did not crack the surface. It was smooth, restricted, and synchronized across multiple readings. A natural fracture deep inside a small body would normally cause some visible effect at the surface. A plume, a collapse, a change in shape. 3I Atlas showed none of this. Outside, it remained visually unchanged, its faint glow and dusty coat undisturbed. It looked as if the interior had moved without transmitting stress to the exterior at all. At the same time, magnetometers registered another anomaly. They saw a small, organized spike in the magnetic field surrounding the object at the exact moment of the internal movement. The spike was weak, but followed a defined waveform rather than random fluctuations. The pattern resembled the magnetic trace of a coil turning on and then off, like a loop of conductive material carrying a burst of current. Some researchers argued that this was only a superficial similarity and warned against jumping to conclusions. Others pointed out that it was becoming harder to explain the data using only ice, rock, and ordinary space processes. The timing made the situation even more tense. The internal motion happened just after 3I Atlas passed through the outer edge of Jupiter's magnetosphere. Jupiter's magnetic field is the largest of any planet in the solar system. It extends millions of kilometers into space and is strong enough to induce electrical currents in conductive materials far beyond its visible atmosphere. One group suggested that the magnetosphere might have triggered some kind of phase change in exotic ices below the surface. Another group noticed how closely the magnetic variations were linked to the internal shift and argued that the object had not just passed through a field, it had reacted to it. In that view, the magnetosphere had not simply been a background condition. It had acted more like a key. Something inside 3I Atlas behaved as though it had received power or a wake-up signal after a long period of dormancy. Shortly after the second movement, high-resolution surface images recorded another brief event. Faint geometric ripples appeared again, this time with clearer structure than before. Fine lines, arcs, and patterns resembling hexagons and spirals spread across the same surface region that sat above the shifting interior. For a moment, it looked as if an underlying framework had pushed outward, pressing against the dust and ice. The patterns then faded, and the surface returned to its earlier, featureless appearance. The ripples did not last long. They were visible only for a few seconds, and only in certain wavelengths. Yet they displayed symmetry that natural erosion and simple thermal cracking could not easily produce. They lined up with the calculated position of the internal displacement, as if both events were parts of a single process. Private meetings grew more intense. Teams rechecked every piece of information, compared models, and argued over interpretation. Some held to natural explanations, stretching the limits of known physics to keep the object within that frame. Others began to consider that the interior might include some sort of structured arrangement, something like layered cavities or ordered plates, capable of moving in response to external fields and heat. A small number went further and used a word many tried to avoid: vessel. Even then, official language remained conservative. Public summaries spoke only of an interstellar object, showing unusual internal activity linked to magnetic and thermal changes. But inside the research community, another description was taking shape. 3I Atlas was no longer seen as a passive visitor. It looked like something that could react to its surroundings with purpose. One fact stood out: the interior did not jitter randomly. It moved, paused, and then moved again in the same way. The direction, distance, and timing of the shifts matched from one event to the next. A natural body does not test its own limits or run through repeated cycles without a clear external push. Here, the push appeared to be an environmental condition, yet the response had the pattern of a system running a check. For generations, astronomy had treated celestial objects as obeying the same simple rules: gravity, conservation of energy, conservation of angular momentum, thermal transfer, radiation pressure. Even complex phenomena could be reduced to these principles. Comets broke apart because of internal stress and heating. Asteroids changed their spin because of uneven warming and cooling. Dust clouds collapsed because of gravity and cooling. Every motion had a cause that could be traced. The behavior of 3I Atlas began to challenge that comfortable picture. Data from NASA, the European Space Agency, and independent observatories all pointed in the same direction. Something inside the object was moving in a way that did not fit the normal grammar of celestial mechanics. Before the internal shifts, analysts had already noticed a slight but persistent wobble in the object's rotation. It drifted and precessed in a way that was unusual, but still could be squeezed into complex natural models. After the internal events, the rotation changed character. It became more regular. The wobble decreased. The spin moved closer to a steady state. In simple terms, the object seemed to have corrected its own motion. In natural systems, angular momentum is one of the most reliable quantities. It remains constant unless acted on by a torque. For a drifting body in deep space, that torque usually comes from external sources: gas, jets, impacts, tidal forces. In this case, no such external force was detected. The change had to come from inside. That meant something internal had reconfigured, applying torque to the whole object. This realization forced every existing model to be revised. Internal mass shifting, movement of dense components, or even a more complex gyroscopic system had to be considered. None of these ideas fit comfortably within the standard view of a simple comet-like object. The thermal behavior in the days after the internal motion added to the strain. Instead of slowly returning to a stable pattern, the subsurface layers showed repeating cycles of heating and cooling. These cycles were short and sharply defined, as if heat was being drawn in and then released in controlled steps. Solar radiation alone does not produce such precise pulses. Heat from the sun usually diffuses through material, leading to smooth curves in temperature, not rapid rises and falls. Some researchers proposed that unusual crystal structures or layered materials might be responding in a complex way to sunlight. Others suggested that unknown, highly volatile compounds could be freezing and thawing in tight cycles. But these ideas could not explain the speed and coordination of the changes. No natural substance is known that can cool across large distances almost instantly and then warm again in perfect alignment with other signals. Spectral data deepened the puzzle. When scientists examined the emission from the glowing regions in more detail, they found that 3I Atlas did not produce the broad, noisy bands typical of dust, ice, and gas interacting in a random way with starlight. Instead, it showed narrow spectral lines, sharp and well-defined. They looked more like emissions produced when light passes through organized structures than like the blended output of simple frozen material. The glow behaved as though it originated from a highly ordered matrix. In simplified models, the light corresponded to patterns that would appear if radiation moved through materials arranged with regular spacing at very small scales. Once again, the object looked less like a loose pile of debris and more like something assembled. Then came one more piece of evidence that could not be ignored. As 3I Atlas moved further inward, tracking systems noticed an adjustment in its orbit. The change was tiny, on the order of 0.0002 degrees in its trajectory, but in orbital mechanics, even such small shifts matter. There were no nearby bodies with enough mass to cause that deviation by gravity. There were no observable jets of gas venting from the surface. No collisions were detected. The timing of this orbital change lined up closely with the internal movements. In effect, the object had slightly pushed itself onto a new path. To do that, it had to exert force. Force requires an interaction. In this case, the interaction came from inside. A natural object simply drifting for millions or billions of years should not be able to generate internal forces on command. As 3I Atlas continued its path toward the inner solar system, tracking stations detected a minute change in its course, on the order of roughly 0.0002 degrees. The deviation was extremely small, but in orbital mechanics, even such a shift can carry great meaning. There were no massive bodies nearby to bend its path by gravity. No jets of gas were seen erupting from its surface. No impacts were recorded. The timing of the change matched the internal movements already logged, suggesting that whatever shifted inside had pushed against the rest of the object and altered its trajectory. In space, a change in orbit requires force, and force in this context implies either an active process or a functioning mechanism. A natural body drifting alone through the void for millions of years should not possess either. The scientific community entered a period of quiet unease. Theories that once seemed firm began to split under the weight of new evidence. Discussions that had focused on thermal stress, solar tides, and natural irregularities now shifted toward questions that felt unfamiliar and difficult to accept. Researchers asked whether the interior might not be solid, whether the object could contain separate compartments, whether mass inside it could be moved with intention, and whether the internal motion was not a reaction but a directed action. These were not questions that astronomers typically explored. They belonged to fields like robotics, cybernetics, and system engineering, areas concerned with purposeful behavior rather than cold, inactive debris drifting through space. Yet the data continued to point toward interpretations that challenged old boundaries. The magnetic field around the object added to this pressure. Comets and asteroids do not generate magnetic fields, and small bodies do not form magnetic envelopes. But 3I Atlas showed a faint, organized magnetic structure that changed in step with its internal movements. The field was weak, but its pattern showed signs of alignment and modulation, as though it responded to internal states rather than random environmental forces. It behaved less like leftover magnetism and more like a subsystem adjusting to conditions. Then the geometric patterns returned. A closer review of high-resolution images revealed that the brief surface ripples seen earlier were not random distortions. When researchers aligned the frames and compared them, they found repeating geometric structures, hexagonal clusters arranged in fractal patterns, spirals connected to angular designs. These shapes were too precise and too consistent to be explained by cracking, stress lines, or the shedding of particles. They appeared and then faded without leaving any debris. Their short duration made them easy to overlook, but their symmetry made them hard to ignore. The idea of hidden structure began to take root. Natural processes rarely hide the patterns they produce, but engineered systems often do. As more data arrived, the discussions among scientific panels grew quieter and more cautious. Some researchers insisted that the object could still be natural, shaped by extreme conditions unfamiliar to humanity. The universe is vast, and it is possible that unusual materials or processes exist far from our experience. But others pointed out that even unfamiliar materials follow the same physical rules, and nothing about 3I Atlas looked like random variation. Its patterns were coherent, and coherence of this kind can suggest purpose. The object was no longer behaving like something shaped only by geological or thermal forces. It behaved like a system responding to its environment. Whatever occupied its interior had not simply shifted, it had acted. When attention turned back to the outer layers, what once seemed to be an ordinary dusty crust appeared to hold a more detailed story beneath its surface. The earlier patterns had been brief, but now, with the internal movements confirmed, researchers returned to archived images with new intent. Across data from ground observatories, Hubble's optical systems, and the James Webb Space Telescope's infrared instruments, subtle shapes appeared along the surface. They formed as the object cooled or as magnetic fluctuations passed through it. Hexagons aligned in organized lattices, spirals spread across the crust with clear geometric precision. Radiating lines extended outward as if marking seams or boundaries. Each pattern vanished quickly, but their consistency across instruments made them impossible to dismiss. At first, astronomers suspected artifacts, noise, diffraction, or overcorrection in the imaging software. But when dozens of images from different sources were synchronized, the same motifs appeared in the same locations at the same rotational angles. They emerged only during internal movement or thermal changes. Patterns do not synchronize with electromagnetic signals unless structure lies beneath them. Mapping the locations of the ripples revealed something even more striking. The shapes formed a coordinated arrangement, distributed along a broad ring on one hemisphere. The pattern was too orderly to resemble geological layering. It looked more like a designed arrangement, not a natural scatter. This led to a hesitant but growing idea. The patterns were not the surface being shaped by stress. They were glimpses of something beneath the surface, trying to express itself. The dust and ice acted like a thin covering, masking a structure that became briefly visible when internal energy passed through it. Magnetic data deepened this concern. Instruments on Earth and on spacecraft detected a field that was weak but consistent, and it rose and fell in rhythm with the object's thermal pulses. Natural magnetic fields do not behave this way, especially around bodies too small to sustain internal dynamos. 3I Atlas lacked the mass and composition to generate its own magnetic system, yet the field persisted and showed a clear pattern, responding to internal motion and electromagnetic pulses. The entire system, heat absorption, magnetic changes, geometric expression, behaved like linked components of a larger mechanism. This was when the phrase systemic anomaly entered official documents. One respected researcher, Dr. Lynn Carver of MIT, wrote in a confidential report that if the behaviors were random, they represented the most organized randomness ever recorded. It was becoming difficult to avoid the conclusion that something internally was functioning. The debate narrowed to two main possibilities. Either 3I Atlas was a natural object of extreme and unprecedented complexity, a type of crystalline formation shaped by unknown cosmic forces, or it carried an underlying structure not formed by natural processes. Both options posed challenges. Further study of the geometric patterns showed that their spacing matched ratios found in quasi-crystalline structures. On Earth, quasicrystals are rare and difficult to form. Those capable of changing configuration are entirely synthetic. The idea that such structures appeared inside an interstellar object created tension across theoretical fields. These patterns do not arise spontaneously. They require conditions that resemble controlled environments, not random cosmic drift. As this analysis developed, spectroscopic readings revealed faint signals with precise timing. Small spikes in energy appeared at regular intervals after the internal movement events. The signals were extremely weak, but they repeated with such accuracy that the possibility of coincidence became small. The intervals between the spikes shortened slightly with each thermal cycle, as if the internal structure was becoming more active or adjusting to the solar environment. It began to resemble a response pattern, not noise. During this time, the object's rotation, once uneven, gradually stabilized. This stabilization suggested redistribution of internal mass, much like spacecraft adjust their orientation by shifting internal components. Natural bodies do not correct their own spin, yet 3I Atlas rotated with increasing order as it moved through the solar system. The faint emerald glow deepened as well. It grew brighter when magnetic fluctuations increased, almost like a visible expression of internal energy transfer. Many researchers no longer viewed the glow as a chemical reaction. Instead, they saw it as light passing through organized materials or energy moving through layered structures. Some proposed that superconductive behavior could be involved, triggered by solar radiation. Others suggested a photonic effect caused by internal lattices routing energy in specific ways. Regardless of interpretation, one conclusion continued to grow stronger. Something inside 3I Atlas was regulating its own behavior. It was not just reacting, it was adjusting, aligning, and acting with consistency. Each anomaly reinforced the sense of internal logic, a logic that did not belong to simple fragments of rock and ice. The object no longer resembled an inert relic of interstellar travel. Its actions were patterned, coordinated, and repeated. Beneath the ancient material coating its surface, something long dormant appeared to be waking. The change was not abrupt, but slow and steady, like a system coming online in stages. For the first time, the scientific community faced the possibility that an interstellar object could behave with intention, or at least follow internal rules that mimicked intention. In the days after the geometric events, researchers focused their attention deeper inside the object, toward the region where the first movements had been detected. As the analysis continued, researchers directed their attention deep into the region where the first signs of motion had appeared. They processed thousands of frames through advanced imaging tools, searching for faint temperature shadows and subtle shifts in brightness that might reveal more about what lay beneath the crust. Slowly, the signals began to resolve. What they had once assumed was a single internal movement no longer appeared isolated. Instead, it soon resolved into a sequence of subtle shifts. The internal shifts inside 3I Atlas were not random. They were not the slow collapses and cracks of geology breaking down over time. They formed a pattern, appearing at regular intervals. Each movement was tiny, often only a few centimeters. But when scientists plotted them in order, they created a clear map of internal activity. It looked less like a lump of material settling and more like parts of a system unfolding according to a plan. The first strong clue came from the James Webb Space Telescope's thermal imaging. Beneath the crust, under meters of dust and ancient frozen material, a network of temperature gradients appeared. At first, the gradients looked like normal subsurface heat flow, the kind you would expect as an object warms unevenly in sunlight. But as 3I Atlas entered regions with slightly different solar conditions, the pattern did something unusual. It did not change randomly. The cooling and heating zones shifted in a coordinated way. Inside a typical asteroid or comet, temperature is messy. Sunlight, shadows, internal voids, and different materials create chaotic patches of hot and cold. 3I Atlas behaved differently. Its temperatures oscillated like parts of a feedback loop. When one region cooled, another heated up in direct response. When one area brightened in infrared light, a neighboring region dimmed. It looked as though the interior was regulating its own thermal state, instead of simply accepting whatever the environment imposed. The data grew stranger when scientists studied the shadow patterns forming beneath the surface. Using advanced light curve inversion and subsurface imaging models, they built a rough map of cavities and voids inside the object. These were not the irregular, jagged pockets commonly found in natural comets. They were angular and symmetrical. Some were long, stretched shapes. Others were nearly perfect spheres. Their arrangement was too orderly to be explained by nature's usual processes. The interior looked less like broken rock and more like constructed space. These cavities did not sit still either. They reacted to heat. As the object rotated and its surface warmed and cooled, the shapes of the internal voids shifted slightly in size or position. The effect was too small to see directly in images of the surface, but sensitive instruments picked it up as changing patterns of shadow and temperature. It was as if internal walls or boundaries were adjusting themselves in a repeating sequence. This internal motion lined up exactly with the electromagnetic pulses that had already been observed. The pulses were not random bursts of noise. They came right after each internal shift, as though released by tension in the structure or by signals passing through layers of material. The electromagnetic signature was extremely faint, detectable only to the most sensitive receivers, but its timing was exact. After each thermal drop, there were 3 pulses. Before each internal displacement, there were 2 pulses. The pattern repeated over and over, like steps in a simple code. Engineers at the Jet Propulsion Laboratory compared the sequence to known mechanical activation cycles, such as those used in complex systems that move through stages of alignment or internal checks. The resemblance was uncomfortable. The more they compared, the harder it became to dismiss the similarity as coincidence. The most striking realization came when researchers overlaid all the major signals: thermal shifts, electromagnetic pulses, magnetic changes, and surface patterns. All of them lined up on the same timeline. The object cooled, then it pulsed, then it shifted internally, then it warmed, then it displayed geometric forms on its surface, then it went quiet again. The cycle repeated. This was not random, it was ordered. It behaved less like geology and more like a routine. Something inside 3I Atlas appeared to be running a procedure, like a program or a cycle in a machine. It did not look new. It looked very old, weakened by age and covered by dust, but still capable of operating. As this picture took shape, theories shifted. Early ideas about strange crystals began to evolve into more structured models. Some researchers suggested that the interior contained a reactive core, a type of material designed to respond only under certain conditions near a star. Others pushed further, proposing that 3I Atlas might be carrying a dormant mechanism built to wake up when it reached the presence of a sun. These ideas would normally be dismissed as speculation, but the data now gave them serious weight. One model described the internal cavities as parts of a heat management network, absorbing and releasing thermal energy in controlled cycles to keep the system within certain limits. Another model treated the electromagnetic pulses as low-level activation signals, similar to a device powering up or running through calibration steps. A third and more difficult idea suggested that the small internal shifts were part of an unfolding process, like an object that had been folded tightly and was now beginning to open. None of these models, however, fully prepared anyone for what tomography revealed in the deepest region. When scientists examined the shifting subsurface shadows more closely, they saw signs of a central chamber far below the outer layers, beyond the visible geometric structures and beneath the thermal cavities. This chamber did not resemble anything known in natural astrophysical bodies. In simulations, it appeared as a smooth, nearly perfect sphere, centered and symmetric. The models suggested that this chamber held either uniform material or something that did not leave a clear signal. But during the internal cycles, it behaved in a way that alarmed researchers. At the peak of each thermal cycle, the chamber expanded by a few millimeters. It did not collapse under stress. It did not distort into irregular shapes. It grew slightly, in all directions, with precise uniformity, then returned to its previous size. Natural voids do not act this way. Under changing pressure or temperature, they crack, deform, or collapse. They do not expand smoothly and evenly. The central chamber behaved less like a gap in rock and more like a component adjusting for activation in the tiny fractions of a second. Right after each expansion, the electromagnetic pulses strengthened. The timing was exact. Heating, chamber expansion, pulse activity, internal shift, surface glow, magnetic fluctuation. Taken together, all of this made 3I Atlas look less like a simple object and more like a layered system. A system that was no longer fully dormant. A system that seemed to be preparing, tuning itself, and adjusting according to rules that had been in place long before humans could observe them. The more scientists watched, the more it became clear that they were not just recording slow physical change, they were seeing behavior. As the central chamber continued its subtle expansions, always linked to the cycles of heat and pulses, another disturbing development appeared. The object, once modeled as following a passive, predictable orbit through the solar system, began to change its path in ways that no natural small body should. The first shift was extremely small, a deviation of roughly 0.02 degrees. In most contexts, such a change might seem unimportant, but in orbital mechanics, even such a tiny angle matters. Objects in space do not change course without force. Ice does not steer. Dust and stone do not produce thrust on their own. Yet, 3I Atlas had altered its path. The timing of the shift lined up with the strongest internal pulses recorded so far. Trajectory specialists at NASA were the first to notice. They scanned for possible causes: gravitational tugs from Jupiter or Mars, subtle variations in the sun's pull, or small impacts from unseen debris. Their simulations returned the same result again and again. No external factor could explain the deviation. There had been no solar event strong enough to push the object. No gravitational field had changed. No outgassing jets had been seen. The orbit had shifted without a measurable push from outside. The anomaly was sent to orbital dynamics teams for independent confirmation. They used different software and separate tracking data. The conclusion held: the change was real. Soon after, another effect appeared. Over a period of about 2 days, 3I Atlas increased its speed by a small but statistically reliable amount. The increase was so slight that it would have gone unnoticed without the close attention now focused on every variable. Normally, objects speeding up or slowing down in the solar system do so because of gravitational assists, drag from thin gas, or jets of material venting into space. 3I Atlas showed none of these. Its surface remained quiet. No plumes of gas, no visible dust jets. The temperature changes were internal, not expressed as thrust. The result was motion without a clear physical driver. This forced scientists to reconsider every piece of internal data. If the structure inside could move mass, it could change the object's center of mass. If it could change the center of mass while rotating, it could adjust the axis of rotation. And if it could control rotation, even slightly, it might be able to use the steady pressure of sunlight and the solar wind to nudge its trajectory over time. That would make it, in effect, steerable. The idea that 3I Atlas might be able to guide itself spread quietly through research groups. Few were willing to say it in direct terms, but many began to think of the object not as being moved, but as moving itself within the boundaries of physics. The next clue came from the magnetic field. Previously, the field had risen and fallen in phase with internal pulses. Now the magnetic pattern began to show clear asymmetry. It was stronger on one side of the object than on the other. This uneven envelope lined up with the direction of the trajectory shift, as though the internal process had created a lopsided magnetic region that could interact more strongly with the flow of charged particles from the sun. Magnetic steering is impossible for ordinary rock or ice, but a structure using advanced, conductive, or superconductive materials and controlling its magnetic flux with precision could in theory generate a small but steady pressure against the charged particles streaming outward from the sun. Some researchers began to describe what they were seeing as a kind of magnetic sail. It did not appear strong enough to drive the object with obvious thrust, but it seemed strong enough to steer. A few theoreticians quietly suggested that the internal pulses might be part of a mechanism that adjusted this magnetic envelope, changing how the object interacted with the solar wind. In that view, 3I Atlas was not just reacting to the sun's charged particles, it was shaping the flow around itself. The idea sounded like science fiction, yet the data continued to support it. The James Webb Space Telescope provided some of the clearest clues. When its measurements were combined with models of the solar wind, scientists noticed that the electromagnetic pulses did not radiate evenly in all directions. Instead, they formed a faint cone of emission, slightly stronger in the direction that matched the change in the object's trajectory. This meant the pulses were directional. The object was selectively pushing energy into one part of its surroundings more than others. That realization changed the tone of many discussions. It suggested that 3I Atlas was not only being pushed by the environment, it was also pushing back in a controlled way. Behind closed doors, debates began that did not just question equations or measurement techniques. They questioned assumptions about what kinds of objects could exist in the universe. If 3I Atlas could adjust its path even slightly, in a repeatable way, then humans were not simply watching a natural process. They were watching navigation. Navigation does not have to mean intelligence in the human sense. It can be pre-programmed. It can be automatic. It can be the remnant of a system built long ago, still operating at reduced capacity. But navigation, even in this minimal form, is not something natural ice and rock perform on their own. The timing of the course change made the situation even more troubling. The deviation occurred right after the object left Jupiter's vast magnetosphere. Many scientists already suspected that Jupiter's field had played a role in awakening the internal mechanisms. Now it looked as though that passage had provided not only a trigger, but also the energy needed to begin the next phase of activity. It was as if 3I Atlas had waited to pass through a strong magnetic environment before adjusting its behavior. This led to a darker question. Was the object simply responding to the nearest strong field, or was it homing in on something? A homing mechanism implies more than reaction. It implies that the object has a preferred state or location and can adjust its path to approach it. That, in turn, implies a designed purpose and a destination, even if unknown. It suggests that the journey of 3I Atlas was not a random wander through interstellar space, but part of a path set across very long timescales. The actual change in course was very small, but in the context of cosmic travel, small corrections can mean the difference between missing everything and arriving exactly where intended. The solar system, once thought of as a stage where random visitors sometimes appeared, now looked more like a place where at least one visitor was making controlled, careful adjustments. A system was adapting to conditions, aligning itself, and perhaps preparing for something. Long before the course change shocked mission planners, and long before the central chamber's expansions were identified, a more speculative idea had already taken root in a few minds. It had begun as a private thought after the first geometric patterns were seen crossing the surface. As each new anomaly was added to the record, that thought grew, moving from unspoken concern to quiet, encrypted exchanges, and eventually to guarded in-person conversations. The idea eventually received a name: the vessel hypothesis. Few scientists wanted to use it, because doing so meant stepping from the study of natural bodies into something closer to archaeology on a cosmic scale. But the evidence increasingly supported a view of 3I Atlas as more than a shaped rock. It behaved like a vessel that had traveled for a very long time through interstellar space, coated in dust and worn by cold, but not completely lifeless. Its anomalies did not appear scattered. They lined up. Its structure was not chaotic. It was ordered. Its internal behavior was not one of random strain. It was systematic. A natural object can certainly be unusual and even unique, but 3I Atlas displayed many coordinated traits that together pointed away from accident and toward construction. One of the strongest early supports for the vessel hypothesis came from its apparent lack of origin. When astronomers traced its path backward, they did not find any obvious parent system. There was no crowded star-forming region, no obvious gravitational sling, no clear point of ejection. Instead, its route led through a sparse area between clusters, a region where matter is thin and quiet. There is no known natural process there that would be likely to launch such an object with so much speed and such a precise, isolated trajectory. It was as though the object had been placed in that region intentionally, set loose into interstellar space with no obvious home. Its solitude added to this impression. Many interstellar fragments likely travel in groups or as broken pieces of larger structures. 3I Atlas, however, traveled alone. No other bodies with similar path and speed were observed in front of it or behind it. In a universe full of clusters, chains, and chaotic debris, its isolation stood out as statistically unlikely. It moved like a single messenger without a traveling group. If it was a vessel, then its structure had to support that idea. Data from its surface and interior suggested that it did. The symmetry of the geometric ripples did not look like random cracking. They suggested repeated patterns. The quasi-crystalline arrangements revealed by its spectrum echoed materials on Earth that are only made in laboratories. Those materials are valued for their resistance to damage and their ability to remain stable over time. It was reasonable to think that if someone wanted to build an object to endure for millions of years in open space, such materials would be useful. In that light, the outer crust of 3I Atlas began to look like armor. Over ages, it would collect dust, ice, and micrometeorite scars, slowly coming to resemble a normal comet or asteroid. To any less advanced observer, it would appear ordinary. Only detailed, high-precision instruments would notice the underlying structure. The internal cavities added to this picture. Natural comets contain irregular voids formed by the loss of ice or the breaking apart of weak rock. The cavities inside 3I Atlas did not fit that pattern. They were smooth, regularly shaped, and laid out in a radial pattern around the central spherical chamber. They looked less like cracks and more like compartments. They might be storage spaces, containment cells, system housings, or something that does not map cleanly onto human terminology. But they did not look like the result of random, slow damage. One model proposed by engineers at the Jet Propulsion Laboratory imagined that these cavities formed part of a propulsion or control system instead of burning fuel. Such a system might use the careful manipulation of electromagnetic fields to push against the solar wind and other environmental factors. In that scenario, the recent signs of internal twitching were the earliest stages of that system trying to work again, like a muscle remembering how to move after a long sleep. The vessel hypothesis did not require that 3I Atlas be a traditional spacecraft in the human sense. It did not have to carry a crew or engines that looked familiar or a pilot at all. It could simply be a construct designed to travel long distances and survive long times without constant oversight. If such an artifact existed, the next question was why it had been built. What purpose could it serve? Three main ideas began to form. The first was sometimes called the seed vessel theory. In this interpretation, 3I Atlas might carry biological material in some form, from simple building blocks to complex genetic instructions. A civilization might send out many such vessels, hoping that some would eventually reach environments where life could take hold. The vessel would remain inactive until exposed to suitable conditions near a star, at which point it would slowly awaken, test its surroundings, and possibly release or activate what it carried. The thermal cycles could be environmental checks. The pulses could be sensing routines. The chamber expansions might be part of early preparation for release. The second idea was known as the data repository theory. Here, the vessel would be an archive rather than a seed. A long vanished civilization might have encoded its knowledge, history, or technology in durable crystalline matrices designed to outlast stars. The object would drift between systems, its contents safe inside. Under this view, the pulses and geometric patterns might relate to internal checks, damage assessments, or attempts to read or rewrite portions of its own stored information when enough energy became available. The third idea was the autonomous probe theory. This was, in some ways, the most unsettling. In this interpretation, 3I Atlas was not simply carrying an important thing, it was the important thing. It would be a device built to travel and observe, perhaps also to react under specific conditions. It might hide within a shell that looks natural, making it harder to distinguish from background debris. It would awaken only when it encountered a combination of factors, such as a star of a certain type, a magnetic environment of a certain strength, or signals of technological activity. Under this theory, the gentle course correction observed after Jupiter's magnetosphere would not be an incidental adjustment. It would be part of an orientation process. The object could be positioning itself with respect to the Sun, or to Earth, or to some other target within the system. The system might not need obvious thrust or bright emissions. It could rely on small, precise interactions with magnetism and light over long spans of time. In all three interpretations, Jupiter's magnetosphere played the role of a trigger. In the first, it might awaken a biological or pre-biological payload. In the second, it might power up an ancient archive. In the third, it might start or resume a probe's long-designed routine. None of these possibilities could be proven, but none could be easily ruled out, given the behavior already observed. The vessel hypothesis did not become prominent because people wanted it to be true. It rose to the center of discussion because other explanations failed to match the full set of data. For the first time, serious scientists had to consider that humanity might not only be watching distant objects, but might, in some sense, be the subject of another system's attention, even if that system was old, automated, and indifferent. As the vessel hypothesis gained traction, the scientific world moved into territory that once belonged mostly to speculation and fiction. But this time, speculation was guided and constrained by measurements. The behavior of 3I Atlas had moved far beyond what could be explained by standard astrophysics. Planetary science, cosmology, and the study of advanced materials all had to stretch beyond their usual boundaries to engage with what the object might be. The more the data were examined, the more 3I Atlas looked like a machine in the broadest sense, a structure built to endure, to persist, and to function across great distances and timescales. Its inner workings remained unknown. The principles behind its design were hidden. The origin of its strange geometries, its regulated thermal cycles, and its shaped magnetic field could only be guessed at. Faced with these questions, leading institutions around the world began assembling teams to build models that might explain the object. Some of those models were cautious and conservative, others were bold extensions of current theory, and some were deeply and profoundly unsettling. These new ideas did not appear because anyone wanted them. They appeared because the measurements left little room for ordinary explanations. As the data refused to fit any familiar natural pattern, three main lines of speculation emerged, each grounded in a different part of physics. The first was the superconductive core theory. It began with a simple but unsettling question. Could the object's internal movements be driven by electromagnetic forces instead of by cracking rock or shifting ice? The electromagnetic pulses coming from 3I Atlas were extremely faint, but their regularity made them hard to treat as random noise. In human technology, superconductors, materials that carry electric current with almost zero resistance, can create very clean, patterned, magnetic fields, especially when arranged in repeated lattice structures. On Earth, superconductivity is fragile. It requires tightly controlled conditions, often temperatures close to absolute zero. But 3I Atlas had spent millions of years in deep interstellar cold, in an environment where exotic superconductive states could remain stable for very long periods. Under such conditions, a network of superconductive paths could stay dormant until disturbed by a strong enough magnetic field, such as the one around Jupiter. The magnetic behavior seen near the object including what looked like flux pinning and Meissner-like exclusion of fields, lined up strangely well with known superconductive effects. Small changes in these fields could, in theory, allow the object to change its orientation by pushing against the solar wind and other charged particles without using jets or visible thrust. If this model was correct, then the interior of 3I Atlas was not just cargo space, it was a functioning machine core preserved in interstellar deep freeze, designed to wake only when it entered a certain kind of magnetic environment. The second idea was the crystalline data chamber theory. The internal cavities, smooth and symmetrical, did not belong to the messy world of natural voids. Nature rarely makes nearly perfect spheres and long, regular chambers inside small, violent bodies. Their geometry reminded some scientists of designs used in theoretical memory storage devices. Dr. May of Caltech put forward a bold explanation. These chambers could hold crystalline data structures with information encoded in the precise arrangement of atoms. Such crystalline cores would have important advantages over digital electronics. They could resist strong radiation. They could survive extreme cold and heat. Their internal order could remain intact for millions of years. If the cavities inside 3I Atlas were data chambers, then the internal shifts might be equivalent to reorienting or indexing those structures, the way a reader might turn pages in a very old book. The geometric patterns seen on the surface could be side effects of internal realignment. As crystal lattices responded to heat and magnetism, the pulses might serve as internal checks, verifying that stored patterns were still readable. In that picture, 3I Atlas would be more than a vehicle. It would be a library, a vault of information moving between stars. The idea was sobering rather than romantic. It meant that the object might contain records from a time long before human history, stored in a medium designed to endure cosmic conditions. The third interpretation was a more advanced form of the autonomous probe theory. In this view, 3I Atlas was not simply carrying something important. It was itself an instrument. An autonomous probe disguised as a comet-like body could travel through space for ages without drawing attention. Its goals did not require consciousness as humans understand it. It might only need to gather data, to sample the environments of new stars, to wake when certain triggers were present, to adjust its position, and then to fall quiet again. Ideas like self-reproducing machines and long-lived interstellar probes had existed in human thought for decades, often under names like von Neumann machines or Bracewell probes. Until now, they had remained speculative sketches in papers and books. 3I Atlas, however, behaved in ways that echoed those sketches. The internal cycles resembled scheduled activation routines. The expansions of the central chamber looked like controlled mechanical tests. The pulses matched low-level communication or control signals. The small course correction suggested that the object was not drifting freely, but orienting itself on purpose, perhaps toward the sun, toward Earth, or toward some other reference. Material scientists added more fuel to these ideas when they examined details hidden in the spectrum of the geometric surface features. Certain wavelengths hinted at alloys that did not match any known natural combination of elements. These exotic metallic compounds might behave in unusual ways under solar radiation, producing the brief luminous patterns observed on the surface. One researcher suggested that the outer shell could be made from a self-healing composite, a material able to reorganize itself to maintain structural integrity. In that case, the glowing shapes might be early signs of repair activity, the surface adjusting as internal systems woke. Others suggested that the patterns were the first hints of an unfolding process with outer layers preparing to open or change configuration. The most extreme models described a layered design: an outer camouflage layer resembling dust and ice, a middle shell with geometric and quasi-crystalline order, inner chambers arranged around a central core, and at the center, the spherical region expanding in measured cycles. If the object was indeed a machine, its construction used principles far beyond current human engineering. Each new theory circled back to the same question: what was all of this for? When engineers build systems, they build them for reasons such as endurance, communication, preservation, exploration, replication, or observation. A seed vessel would suggest distant makers trying to spread life. A data chamber would suggest archivists trying to save knowledge. An autonomous probe would suggest explorers or watchers who may not be present anymore, but whose tools still operate. One sobering idea was that 3I Atlas might come from a civilization that no longer exists. Its creators could be gone while their devices continue to move through space, carrying out missions, or simply surviving, long after any living memory of their origin has vanished. In that case, the object would be both a machine and a relic, an artifact from a history written on another world. Whatever the truth, it became harder to avoid one conclusion. The object did not only show strangeness, it showed signs of engineering. Its interior behavior, surface geometry, and response to the environment fit together too neatly to dismiss as chance. The slow, ordered awakening of its internal processes suggested that some original purpose, whatever it had been, was now beginning to express itself. Jupiter's region of space became central to many of these theories. The giant planet's magnetosphere is enormous, a vast bubble of magnetic influence extending far beyond its visible surface. If human eyes could see it, it would appear larger than the full moon in Earth's sky. Charged particles spiral through this field, forming powerful radiation belts that can damage electronics and confuse instruments. No object passes through this region entirely unaffected. When 3I Atlas entered the outer edge of this magnetic domain, scientists expected small effects: minor electrical disturbances, charging of the surface, perhaps slight changes in temperature from particle impacts. At first, these expectations seemed reasonable, but the object's reaction went well beyond simple noise. It behaved as if Jupiter's magnetosphere was not just a harsh environment to endure, but a switch it had been built to recognize. The first sign was the sudden internal temperature drop. It was almost instantaneous and very deep, like a system drawing energy from a new source. The timing was exact, occurring just as the object moved into an area where the magnetic field strength rose sharply. Shortly after, the pulses strengthened. They became clearer, faster, and more frequent, coming from the interior and propagating outward through the crust. They traveled across the mapped cavities, like signals tracing paths through a network of components. Days before, the pulses had been barely visible in the data. Now they were distinct, and their pattern matched the peaks and troughs of Jupiter's magnetic environment. It was as if 3I Atlas recognized that it had entered a particular kind of space, one that it had encountered before or had been designed to use. One group of researchers argued that Jupiter was acting as an energy source, with its magnetosphere supplying power to induction systems inside the object, especially if those systems contained superconductive elements. Another group suggested that resonance might be involved, with certain frequencies in the planet's field matching natural frequencies inside the object's materials and thus triggering activity. A smaller, more cautious circle went further, and asked whether the object was designed to wake up specifically in fields like Jupiter's. Not just any magnetic field, but one with particular strength and variability. Jupiter's magnetosphere is not only the strongest of any planet in the solar system, it is also highly dynamic, with fluctuations strong enough to affect distant spacecraft. Missions like Voyager, Cassini, and Juno have all recorded its complex behavior. If an artifact built to respond to powerful magnetic environments wandered into this region, Jupiter would offer exactly the kind of stimulus needed for activation. This idea had heavy implications. It suggested not only design in the object itself, but design in the way it would interact with certain environments. A vessel meant to awaken under strong magnetic conditions might be intended to do so only when the discoverers were capable of noticing. Such a civilization would need sensitive instruments and an understanding of magnetism and radiation. It would need to be at least as advanced as current human science. As 3I Atlas moved deeper into Jupiter's magnetic field, its responses grew stronger. Surface patterns that had once been faint became clearer and lasted longer. New observations reported that some of these shapes now emitted a soft violet-tinted light at wavelengths not previously associated with the object. The patterns held for nearly 8 seconds at a time before fading, and their timing matched the expansions of the central chamber. The chamber expansions matched the pulses. The pulses matched the changes in the surrounding magnetic field. The cycle formed a closed loop. Field, heat, expansion, pulse, glow, and back again. By the time the object began to leave the central region of the magnetosphere, it had experienced internal shifts many times larger than the first motion that had drawn attention at NASA. It was clearly not in its earlier dormant state. It was doing something. A small but measurable adjustment in its path followed. On its own, the change could have been dismissed, but its timing right as 3I Atlas exited Jupiter's influence made it hard to ignore. It looked like the end of a calibration phase. The object had entered a strong magnetic region, reacted, adjusted internally, and then, as it left, slightly changed its course. Behind closed doors, scientists tried to fit this into a picture that did not require intention. Some refused to go beyond purely physical explanations and warned against seeing patterns where none existed. Others pointed out that the behavior matched what would be expected from a system actively sampling its environment and then updating its state. One proposal described the internal structure as a magnetically reactive architecture designed to absorb, store, and redirect magnetic energy. Another suggested that the vessel might contain very old sensors meant to measure the properties of planetary systems and record them through changes in its own configuration. A third, more radical idea imagined that the object was following a loosely defined path with built-in milestones, waking at certain points and adjusting to remain on track. Jupiter would then have been one such milestone. The Sun could be another. Through all of this, one fact stood firm beneath the disagreements and models. The object was no longer acting like a piece of inert cosmic debris. Whatever else could be argued, its responses to Jupiter and to the solar environment showed a degree of order that no simple natural explanation could fully capture. Yet amid all the speculation, one fact remained irrefutable. Nothing about 3I Atlas's response to Jupiter looked passive. It did not react with random flares or chaotic breaks. It reacted in a sequence. The signals were coordinated, the timing consistent, the internal changes ordered rather than collapsing. It did not look like an object wearing down under stress. It looked like something activating. With each new dataset, theories multiplied. If the object's awakening truly depended on a magnetosphere as strong as Jupiter's, then one possibility was that whoever built it had tuned their devices to wake only in places where large, long-lived stars with stable planetary systems were likely to exist. These systems are the ones most likely to host atmospheres, chemistry, and potentially life. Under that view, vessels like 3I Atlas were not drifting completely at random. They were moving through space with a conditional purpose, waking only when they encountered the right environment. In that scenario, 3I Atlas had finally crossed into a region where its dormant systems could respond. Jupiter's magnetosphere may have supplied the energy and the exact field strength required. At the same time, a technological civilization capable of monitoring magnetic and thermal anomalies now happened to be watching. As the object moved out of Jupiter's reach, its journey continued, but its core no longer appeared inactive. Interior chambers showed repeated motion. Patterns in heat, magnetism, and light no longer fit the profile of a quiet relic. An internal mechanism, buried under dust and ice from another era, seemed to have crossed a threshold from sleep to operation. As 3I Atlas moved toward the inner solar system, its behavior increasingly resisted standard explanations from planetary science, astrophysics, and materials research. The synchronized pulses, geometric surface patterns, and expanding central chamber all suggested a system that responded in a controlled way to its surroundings. The slight trajectory change hinted at self-regulation. The strong reaction to Jupiter's magnetosphere suggested a system that could be triggered under specific conditions. At this point, many scientists began to accept that they were no longer dealing purely with natural astrophysics. They were dealing with something that behaved as if it had a role. Understanding that role required more than measurements. It required a framework. Across different institutions and disciplines, one question came to the center. If this object is some sort of vessel or device, then what is its function? Theories spread out from that question. Some cautious, some more speculative. Over time, 4 main possibilities rose above the rest, each with some support in the data, and each carrying a different set of implications. The first was the silent probe theory, in which the object is a machine built to observe. This theory drew from the small but precise orientation changes and the measured course correction. These features looked similar to the way human-built probes like Voyager, Pioneer, and New Horizons adjust their orientation to point instruments toward planets, stars, or the sun. Under this idea, 3I Atlas might be doing something similar, at a different scale and with very different technology. Its internal pulses could be seen as calibration cycles, helping align internal components with external fields or light sources. The tiny shifts in orientation and path might be efforts to place itself in the best position to scan the solar system or to transmit or store information about it. A silent probe would not need to send obvious signals. It could simply record, adjust, and continue. In this view, humanity had not just detected a random visitor, but had crossed paths with an ongoing survey created long before human civilizations arose. The second possibility was the seed capsule theory, in which the object was designed to spread life or its ingredients. Life as humans know it depends on narrow ranges of temperature and chemistry, but a much older civilization might choose a method that does not rely on fragile broadcasts or direct contact. Instead, they might send robust physical vessels carrying the raw materials or templates for biology. In that model, the smooth, sealed internal chambers in 3I Atlas could be storage zones for molecular structures, genetic patterns, or biochemical seeds. The vessel would remain inert until it detected a suitable star and perhaps signs of stable planets. Then it would begin slow routines, regulating internal heat, adjusting structure, and sampling radiation and magnetic conditions to decide whether to proceed. The small expansions of the central chamber would be early stages in these routines, not yet resulting in any release, but consistent with a system that is warming up or testing itself. Under this theory, the object is less an observer and more a carrier. It might not be aimed at Earth at all. It might simply be acting according to a general rule, respond in any system that meets a set of conditions. Humans are simply the ones who have seen it. The third theory was the archive theory, which described the object as a memory vault from a vanished culture. The symmetry and stability of the inner chambers made some scientists think of storage spaces rather than tanks or engines. Their shape matched what one might design if the goal was to preserve ordered structures over very long timescales. Crystalline memory systems, which store information in atomic arrangements rather than in easily corrupted electronic states, have been proposed on Earth for extremely long-term archiving. If 3I Atlas contained such structures, it could hold information that predates many current stars. In that case, a civilization facing destruction from stellar changes, environmental collapse, or other causes might have built vessels like this and sent them outward as records of their existence. They would not be targeted at any specific receiver. They would simply preserve knowledge somewhere in the universe. The object's awakening near a star could then be part of an automatic check, testing whether conditions are suitable for any potential discoverer to access the data. That interpretation carried an emotional weight that many scientists tried to keep separate from their calculations. The idea that humans might be watching the faint echoes of a species that no longer exists, preserved only in a machine. The fourth idea was the adaptive mechanism theory, in which 3I Atlas is not primarily a container, but a system designed to change itself. In this model, the internal chambers, layer geometries, and pulses serve a more dynamic purpose. They might support a process of self-modification, in which the object gradually rearranges its own structure in response to power sources and environmental triggers. The subtle expansions of the central chamber would then be early signs of a larger transformation. According to some models, a device like this might harvest energy from stars and magnetic fields, repair accumulated damage, and eventually unfold or reconfigure itself into a different shape. The compact comet-like form might only be a transport state, chosen for long-distance travel between stars. Once in a favorable environment, the mechanism could gradually move toward a new configuration. No one knew what that configuration might be, but even this early change suggested that the initial state was not final. Across all four interpretations, one thread remained common. The object's behavior could be mechanical, without consciousness. In human thought, purpose is often linked with awareness, but complex machines on Earth already perform tasks, make corrections, and follow routines without any form of understanding. 3I Atlas could be following rules written long ago. It could be carrying out steps in a process that has no flexibility, simply responding whenever the conditions match its design. It could be completing a mission, or it could be failing one, or entering a mode never intended by its makers. Human concepts of intention may not apply cleanly to such a system. As more evidence accumulated, another question slowly moved to the center of discussion. Instead of only asking what the object was, many scientists began to ask, why now? Why had its systems stirred at this point in time? Why in this solar system, after what likely were immense stretches of quiet travel? Why so soon after passing a planet with an unusually strong magnetosphere. And why, during the era when humans had enough instruments and collaboration to notice, many tried to argue for coincidence. Random timing is always a possibility, but with each confirmed anomaly, coincidence began to feel weaker as an explanation. The awakening was measurable. The internal movements were measurable. The pulses and trajectory changes were measurable. Whatever 3I Atlas had been built to do, it appeared to be starting or resuming that activity now, within the range of human observation. In response, the world's major observatories and space agencies moved from casual tracking to continuous monitoring. Large ground-based telescopes, space telescopes, and spacecraft sensors formed a loose but effective network. Data flowed across continents and between agencies, turning the observation of this one object into a coordinated, round-the-clock effort. It was the first time that so many different instruments, operating in different bands of the spectrum and positioned in such different locations, focused together on a single target for so long. The object itself remained visually unimpressive to ordinary optics, a small, dust-covered body reflecting faint sunlight. But the tools now trained on it were not interested in appearance. They measured temperature changes across its surface and interior. They followed its electromagnetic emissions. They tracked small shifts in its magnetic field and spin. They watched for any sign of outgassing, debris, or impact. The more carefully they looked, the more consistent the unusual behavior became. 3 main observational pillars carried most of the load: the James Webb Space Telescope, the Hubble Space Telescope, and the network of advanced ground-based arrays. The James Webb Space Telescope, with its infrared capability, played the central role in mapping the object's interior. By capturing tiny differences in heat, it allowed scientists to reconstruct where the cavities were, how large the central chamber was, and how these features changed over time. It recorded the sharp internal cooling events. It captured the slow expansions and contractions of the spherical chamber. It caught the faint signs of subsurface geometry emerging and fading. Hubble supported these findings from another angle. Although older, its instruments in visible and ultraviolet light had the speed and sensitivity needed to capture quick changes on the surface. It recorded the hexagon-like patterns and spirals that briefly appeared when the interior was most active. Its rapid image sequences showed how these patterns spread and then vanished within seconds, framing them in time in a way that linked them directly to the internal cycles detected by James Webb Space Telescope. Large ground-based observatories filled in important gaps. Facilities in Chile, South Africa, and other locations used adaptive optics and fast detectors to catch very fine changes in brightness and motion. They recorded tiny surface vibrations at the moments when internal pulses grew strongest. Combined, data from space and ground painted a picture of a structure that was not simply responding to random forces, but moving through a series of linked steps. Magnetometers, both on Earth and aboard spacecraft, provided an equally important window into the object. They acted as listening devices for its changing magnetic field. Instruments in Earth orbit, in solar orbit, and at different points within the inner solar system picked up small but regular changes in magnetic intensity. The changes lined up with internal events. Each time the central chamber expanded, the field dipped by nearly the same amount. Each time the field steadied, new pulses appeared. The pattern was measured independently by several missions, reducing the chance of error. Some spacecraft, such as those already studying the Sun's environment, reported magnetic anomalies pointing away from the axis of the internal expansion, as though the field were being shaped outward along specific directions. Others detected repeated modulations at consistent intervals, like the ticks of a slow, mechanical clock. Small comets do not have their own magnetospheres. 3I Atlas appeared to have one, and that field appeared to be under the influence of whatever was moving inside. These observations led to the next line of investigation: spectral analysis of the light coming from the object, especially in the unusual range associated with its changing surface glow. It was here that spectrometers began to focus on a particular feature that came to be known as the violet signature. Spectral instruments quickly faced a problem they had never been built for. The glow from 3I Atlas, once a simple, faint green, became more complex as it left Jupiter's influence. The most puzzling feature was a narrow violet emission line. It did not match the spectra of common fluorescent materials or ionized gases, and its wavelength pattern matched no known element or simple molecule. Multiple spectrometers, in space and on the ground, recorded the same line. It was clean, stable, and appeared after every major internal event. Its strength rose and fell in step with the object's internal cycles. One idea was that the violet line came from an intermediate energy state inside an unusual material, perhaps a crystalline or superconductive lattice that leaked specific wavelengths when it shifted. Others pointed out that no familiar chemistry produced such a stable pattern and suggested that the emission might reflect interactions in engineered matter. Whatever its origin, the timing was clear. The violet signature always followed the internal pulses. It became a marker that each cycle inside the object had reached its closing phase. At the same time, radio telescopes and radar arrays measured small Doppler shifts in signals reflected from the object. These confirmed that the earlier course change was not a one-time event. 3I Atlas continued making tiny adjustments to its motion. The changes were not large enough to threaten any planet and not irregular enough to suggest breakup, but they were regular in time and linked to the internal cycles. By combining data from deep space tracking stations and large radio observatories, astronomers mapped these micro-corrections. They appeared like slow, patient course alignments. If the object were drifting freely, its rotation and path should have followed only external forces. Instead, it behaved as if it were preserving a chosen heading. Thermal tomography added another layer. Using temperature data and models adapted from asteroid studies, scientists reconstructed how heat moved inside 3I Atlas. The models showed cavities that expanded and contracted slightly, walls that shifted, and channels that seemed to narrow or widen in rhythm with the pulses. Small pressure changes were inferred from these patterns. All of these internal motions were synchronized with the same repeating cycles. Deeper still, the models revealed a central region unlike any other. This inner zone remained almost perfectly uniform. It stayed cold and showed no clear internal features that current methods could resolve, yet every measurable change inside the object could be traced back to it. Thermal drops, magnetic spikes, and pulse sequences either began near this region or converged toward it. Whatever occupied the center of 3I Atlas did not appear directly, but it seemed to control what happened elsewhere. To outside observers, the object remained quiet. It did not send radio messages or obvious beacons. Its visible brightness changed only in ways that matched the internal cycles. To most telescopes, it looked like a dim, dusty body passing through sunlight. But the timing and coordination of its internal behavior told a different story. Each pulse looked like a test. Each geometric ripple looked like a small structural adjustment. Each tiny course change looked like part of a repeating procedure. The instruments that humanity had built to study stars and galaxies were now focused on something that did not fit any known category. It could be described as a vessel, a probe, a library, or a seed, depending on which function one emphasized. No single label was confirmed, but they all shared one idea. 3I Atlas was not only reacting to its surroundings, it was interacting with them according to its own internal rules. As observation continued, the effect on human thinking began to show. For the first time, the same tools that had revealed distant clusters and supernovae were now measuring the behavior of an object that might carry the mark of construction. There was no sign of thought as humans understand it, but there was clear evidence of organized structure and long-prepared response. That alone marked a change. The universe was no longer seen only as a place shaped by impersonal processes. At least one object appeared to carry the imprint of deliberate design. In control rooms and research labs, scientists stayed focused on data quality and error checks. The pulses, course corrections, and surface patterns were treated as measurements first and ideas second. Yet it was hard to ignore how those measurements pointed in the same direction. 3I Atlas was not behaving like a random fragment. It was acting like an arrival from beyond the solar system that had begun to operate within it. For astronomers used to orbit calculations and radiation models, the object was a difficult new kind of problem. For engineers, it hinted at design methods that favored survival across millions of years. Across fields, a quiet thought spread. The universe might contain more long-lasting artifacts than anyone had expected. For generations, people had taken comfort in the idea that the cosmos was distant and indifferent. Stars, galaxies, and comets followed rules that could be written in equations. They did not notice Earth. 3I Atlas did not overturn those rules, but it suggested that not everything in space is simple debris. Signs of engineering may appear not as spoken messages or radio traffic, but as behavior, systems that wake, adjust, and continue when certain conditions are met. Conversations in universities and classrooms began to reflect this shift. Students discussed not only whether life existed elsewhere, but also what it meant to encounter something built far away and long ago. Lecturers who once used only hypothetical examples now had a real case to reference. Slowly, ideas about humanity's place in the universe widened. If 3I Atlas was engineered, then whoever made it understood how to build for timescales far beyond human planning. They had found ways to protect structures from radiation, micrometeorites, and temperature swings for stretches of time that may rival the age of complex life on Earth. Human spacecraft are designed to last years or decades. Our storage media aim for decades or centuries. The object under study may have traveled through interstellar space for millions of years and still retained the ability to respond in a controlled way. This comparison did not diminish human work. It offered a new reference point. It suggested that human technology is still in its early stages when measured against what is physically possible. Studying 3I Atlas became a way to think not only about another civilization, but also about what kinds of long-term projects humanity itself might attempt. Alongside curiosity, unease remained. No one knew what the object's awakening would lead to, or whether further changes in its behavior might affect the solar system. So far, there was no sign of directed harm, and no indication that Earth is a target. But uncertainty alone kept questions alive. The object followed its cycles, made small adjustments, and revealed no explicit message. The silence was not empty. It was filled with measurable actions that hinted at a purpose still hidden from view. In that continuing watch, one conclusion had already taken hold. The universe could no longer be treated as a place defined only by natural structures, at least one object strongly suggested that somewhere, sometime, a civilization had reached out across space in the form of a machine built to last. Whether 3I Atlas is a probe, a seed, an archive, or something different altogether, its measured awakening has already expanded the story that humans tell about what the cosmos contains and how far the traces of intelligence might travel. Wherever the object had come from, whatever had shaped it, one fact was now impossible to ignore. The universe was no longer a place of pure silence. It was a place of echoes, subtle, structured, and finally close enough for humanity to hear. To the naked eye, 3I Atlas still looked like nothing more than a faint drifting point, a quiet speck among countless icy fragments that circle the sun. But to the instruments observing it, and to the scientists studying each shift inside it, the object had become something far more significant. A presence, steady, patterned, unfolding in deliberate steps as it entered the inner solar system. Its internal cycles grew steadier, with distance from Jupiter. Pulses that had once flickered irregularly now appeared in a clear rhythm, as if the system inside had reached stability. The central chamber expanded with predictable timing. The magnetic field aligned into a cleaner shape, smoothing the earlier asymmetries. The object felt poised, not simply active, not merely responsive, but ready. Ready for something no one could yet define. Scientists who once spoke carefully now used language that edged toward agency. Its microcorrections continued, faint, precise nudges that suggested intentional positioning. Its rotation settled into a stable axis oriented toward the sun. Thermal patterns tightened into organized bands, more like controlled routing than random conduction. Everything pointed toward a system that was adapting to its environment, perhaps learning, perhaps remembering how to function near a star. The question was no longer whether the object held complexity. That was certain. The question was whether it was preparing for a transformation. Some believed it might be calibrating sensors, aligning itself to scan the solar system. Others suspected it might be preparing to deploy something information, structure, or material once its chambers reached the right temperature. A smaller group wondered if the expanding central chamber was early evidence of a release mechanism. But another possibility carried a quieter weight. What if the awakening itself was the purpose? What if this sequence was not a prelude to action, but the completion of one? Perhaps the vessel had been built to awaken only when intelligent observers were present. Perhaps its stirring was a message, and perhaps the message was not meant for humanity at all, but simply recorded in its presence for some distant future watcher. Humanity continued its careful observation. The object became a kind of cosmic text, its pulses and patterns studied like lines in an ancient manuscript. Engineers modeled the internal cavities with quiet precision. Philosophers examined the implications of a device built by hands that no longer existed. Yet for all this work, one thing stayed constant. The object remained silent. It sent no radio signals. It produced no clear communication. It did not reply to any probe or beam. It simply moved, aligned, pulsed, and remained mute. But silence is not emptiness. It can be an expression of restraint, or completion, or waiting. As 3I Atlas drew closer to the sun, its surface warmed in ways it had not experienced in its long interstellar drift. Dust lifted, thin fractures glowed, and the geometric ripples returned. But now they lingered, glowing with soft violet light that hinted at deeper layers beneath. The patterns spread slowly, forming spirals, tessellations, and hexagonal pathways designs no natural process could easily create. They resembled a map, or a circuit, or a structural diagram revealed through heat. No one knew what the shapes meant. They might reflect internal adjustments, they might be alignment markers, they might be symbolic, a visual language built into the surface of an artifact. Whatever their purpose, they marked a threshold. The vessel was no longer simply waking. It was revealing. Moments after the geometric patterns brightened to their peak, the magnetic field shifted again, this time forming a steady axis that pointed directly toward Earth. It could have been a coincidence. It could have been an effect of internal stabilization, but the timing made coincidence hard to accept. Debate rose sharply. Was this alignment intentional? Was it functional? Was it a form of recognition, or simply the natural orientation of a system seeking equilibrium? Nothing in the data could answer these questions, but the alignment became one of the most unsettling observations yet. Philosophers asked a question no one could avoid. Was the vessel looking at us? Humanity now occupied a different position in the cosmos, not as explorers searching outward, but as observers, standing before something ancient that had chosen, by design or by chance, to awaken in our presence. It showed no threat, offered no greeting, and revealed no purpose. Yet its existence alone shifted the human view of the universe. Even if 3I Atlas vanished tomorrow, even if it drifted into shadow or burned in sunlight, the awakening had already altered something fundamental. The universe felt closer. The unknown felt articulate. The silence felt expressive. As the object drifted on, the geometric ripples faded. The pulses slowed. The magnetic field relaxed into a soft, steady shape. Whatever sequence had stirred beneath its crust began to ease. Like a long breath returning to calm, the object showed no urgency. It did not accelerate or change course. It simply moved past the world that noticed it, past the star that warmed it, returning to the wide quiet that had carried it for so long. Perhaps it had completed its purpose. Perhaps its purpose was only to be seen. Or perhaps the meaning lay far beyond anything humanity could yet imagine. For now, the sky grew quiet again. Instruments continued their watch in steady calm, and the traveler, wrapped once more in dust and light, slipped deeper into the solar wind, leaving behind a changed Earth, a humbled species, and a quiet reminder that the universe is wider and older than any single mind can hold.